This is the Amp Hour Podcast, recorded January 18th, 2017, episode 332, an interview with Zach from Zachtronics.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
I'm Zach from Zachtronics.
Hey, Zach.
Welcome, Zach.
Thanks for joining us.
Yeah, it's exciting.
This
is our
one is going to be unusual.
Yeah, this is I'm so confused and amused, but like in the best way possible. I just want to say that like this is so cool talking to you because first off, I need to tell people what you make and what you do.
Oh God, that's the problem, right? Trying to explain it.
Sure.
So,
but I think this audience will have some crossover here.
You make video games, right?
We do. So we make video games. So Zachtronics is a game studio. We've been around for years and years now. And back in the day, a long time ago, before we realized it sounded bad, we used to say we made games for engineers. And then we stopped calling it that for a while because who would want to play that? And we've been doing it for so long that we can actually, it's probably better if I say we make games for engineers because we do.
Nice.
And it started off as a coincidence, and then it became a disturbing trend, and now it's just true.
Is that because of the whole new hacker maker, well, not new, but like the last 5 years, maybe it's really gone solid, and now it's kind of like cool to be an engineer slash maker.
Dave, I haven't gotten the news article about that one yet.
I would like to agree, but yeah, I don't know how cool it is, to everybody.
It's not mainstream.
To some degree, I think yes. I mean, it's okay. So I mean, obviously, like a large game success in games is really about getting lucky and getting attention and somehow finding a way to cut through the noise. And I think a lot of times, more often than not, it's not about talent all the way. You have to be talented to some degree, but you really have to be lucky. Yep. And a lot of why we are where we are is because we've gotten lucky. We made a bunch of games and persistently, I started making games for free, and then I made a bunch of games for free, and then I slowly started making games that I sell. And it's been, I don't even want to count, at least 10 years of making games and putting them out there as Zachtronics.
Nice.
I'm pretty sure, it's at least 10 years. And over that time, we've slowly built up so more and more people who are the right kind of people to play our games, the kind of people who will, everybody's the right kind of person to play our games.
The right kind of people. You hear that, folks?
The kind of people who will really enjoy our games for the weird things about them that we'll get into shortly. We've slowly kind of gotten the word out there. So, a lot of those people know about it. And it turns out there's a lot of engineers who like games, especially now. There's a lot of programmers who like games, and they all know us now. And that's great.
That's really awesome.
So how can why do we have a gaming person on an engineering podcast? Games for engineers. Explain.
Well, maybe start where you came from too. Yeah.
Oh, yeah. So I have an engineering background. No surprise there. So I went to, I got a degree in computer science, computer engineering at Rensselaer Polytechnic Institute in upstate New York.
Troy, New York. All right.
Yeah. Oh, yeah. Yeah. And lovely Troy.
Yep.
And so I got an engineering degree there, but that was sort of where I discovered making games. And of course, it just made sense to me that when I was going to make a game, it'd be cool to make games about these things that I was learning about that were really interesting. And
Nerd,
yeah, exactly.
Yeah.
Exactly.
Yeah.
And fortunately, I was at Rensselaer Polytechnic Institute, where most of us were nerds.
Built-in audience.
Right.
Yeah. And it was just normal. And, so I was taking classes about computability and learning about these engineering things and being able, it just kind of fit together in a way that I could make games about it. Mm-hmm. And this is not a common reaction, I think, when most people learn about computability theory, they don't go make games about it. But, but for me, I did.
It's just how you processed it or what?
Yeah, it just kind of made sense. It looked like a game, right? The idea of trying to, if somebody gives you rules for a state machine, or a character recognition automata that can, and they can recognize these different strings, and they say now draw a state diagram that can recognize these strings. That's kind of fun. And I think a lot of people who take these kind of classes, if they kind of get it, that's the part that's fun. The math, the theoretical math part is the not fun part to me.
Right.
But kind of designing these little state machines that would describe these string, routines, that was really cool. And that kind of felt like a game. And so I was learning to make games at the same time. I said, why don't I make games about this kind of stuff? And this was also when, how was it not not How Did It Get Made, How It's Made. Is that the
the TV show you mean?
There's a podcast now about making movies and stuff that's called How Did This Get Made? So I always confuse that. So yeah, like How It's Made, like the show about like factories and how stuff is made. And I was watching, like this was on TV, this was pretty popular then. And I was like, oh man, it would be so cool to make a game where you build these factories and you build factories that make things. And like that's kind of how computers work, is that you program them to transform inputs and produce outputs. And so there's this big space of stuff that overlaps that I was being exposed to at the time while learning to make games. And it just kind of clicked. And I started making Zachtronics games, which is now apparently called Zach Likes. And the characteristics, I did not coin this term. Somebody at PC Gamer. I've been doing this long enough that, like somebody at PC Gamer or Rock Paper Shotgun, one of them, coined the term Zach Likes for the kind of game we make, which is typically they're open-ended puzzle games. And if you think about like what a puzzle game is, you can think of like a ton of different kinds of games. Like Tetris is a puzzle game. I'm doing air quotes.
It is.
Tetris is a puzzle game. Bejeweled is a puzzle game. But Portal is also a puzzle game.
Yeah, that's what I was thinking of. Yep.
And like there's a whole bunch of different kind of things. Like some puzzle games are really just about pattern recognition. Some of them are about reconstructing a solution that the developer created. Ours are about being really open-ended challenges, and where we say that if in order to have completed this level, you need to build a machine that takes these inputs and creates these outputs. But how, like what your machine looks like, because our problem is defined in such an open way that it just has to, we're giving you criteria, not a state. Right. And so we're giving you criteria.
It could be an elegant, really optimized solution, or it can be a complete kludge.
Exactly. If someone's asking you just to find the path to get to a state, you can't really do that elegantly or not elegantly. But if somebody's saying, here's some specifications, just make it happen, right? Like you could have like a really hack job, or you could have like something that's like really like fast and efficient. And that's where a lot of with one of our games, Space Chem, was when we thought to add histograms. And so when you beat a level, you can see a histogram of how everybody else did. And then later you can see little leaderboards of how your friends did. And it turns
I was going to say, do you score points based on how optimized your solution is?
Yeah, exactly. Yeah. So one of like our best metric in any of our games that are like this, that follow this formula, is always cycles. Because people really understand, I need to make this faster. And so with some of our more recent games that are actually about assembly programming, they're literally about cycles of like these fake computers. But even in our more like abstract visual puzzles, it's about like how many like factory ticks does it take to build stuff. And
so is it a certain type of like brain chemistry that likes this stuff too? I mean, like even so like you said, it's kind of games for engineers, but it's also, I mean, I'm sure it's not just that. So do you notice any other characteristics of the people that are playing your games that are similar other than engineer types?
Yeah, I kind of think it's a kind of thing that would appeal to everyone if they could get like past the sort of implicit difficulty curve that's in a lot of these games. Because and this is something that we still years and years later, after making games that kind of have a formula to them, that is this compelling little thing we do. We're still trying to understand like how can we make these games so more people can play them without bouncing off of them. And I think we're kind of notorious for having games that are really, really, really hard. And it's not that we try to make games that are hard, it's just that in trying to make games that are emergent and open-ended, they're often complex, and you often need like a level of systems thinking that you don't for other games. And so it's kind of, we dabbled in educational games for a while, and we still have no idea like how any of this stuff connects, and like it's kind of hard. I don't know, it's above my pay grade. I just make games. I don't understand the human mind.
No,
have
that's
you
great.
Thought about targeting kids for stuff like, because I would think that this is not suitable for an 8-year-old, for example. They wouldn't have that systems engineering thinking, or would they?
Some of them
before they get a beat out of them in school.
Yeah,
high school.
This is how you can identify the knack. You could use this as a testing method for future engineers.
Your next game must be called The Knack.
The Knack.
I might pass on that, but we'll see. Can't promise anything.
Okay.
So we have a lot of people who play our games and have been playing our games, and now they have kids, and now their kids are getting old enough where like they want to like get their kids to start playing these games. And we've had some players who, like, a lot of our games have level editors, so we've had actually some players that have put together like what they believe are a simpler set of levels so that way their kids can play. I sort of have like an inability to relate to kids or any of that. Like I very much like all these games are very much designed for people at like a college level.
Right,
Not to say that you have to be at college level but like that's just sort of when I started thinking about them. And so there's a lot of implicit assumptions in anything that anybody makes, especially these. And but we definitely have lots of high schoolers that I've heard from playing our games. I get emails all the time now. Again, been doing this so long that people have played our games over the years, and it kind of helped them think that they should go to college for computer programming, and now they're like out of college and have careers, and then they can write back and say, "Oh, thanks for helping me decide what to do with my life." And
awesome.
Yeah. So they're games for everybody, but they're
but
definitely
most optimized for.
but not for everybody. And it's
wow.
Yeah. It's a post hoc filtering. We don't want to say like don't try it if you can. It's just you might not like it, and if you didn't, it's because of this.
Right. It's almost like a challenge put out to people too. It's like
it is.
We dare you to try these games, yeah.
Kind of, yeah.
Now this is your full-time job, right? But you've been in. You said before the show that you've been in and out of full-time gaming development.
Oh yeah, I mean,
Tell
like
us
so.
Why, how, and why?
I started making these games when I was in college, and then I got a job at Microsoft where I worked on Office of all things. For some reason,
so you had some kind of creative energy built up at the end of the day that you needed to.
I need to know, is that as boring as I assume it would be?
Oh god. Okay, so I worked on something called Visio, which is a diagramming program.
I used to use Visio, yeah.
I used to use it too. So
it used to be pretty good. I mean,
it is. Yeah, definitely. It's hard to make diagramming programs, and it was a pretty competent one. So I went to work there at Microsoft, and I sort of got like pushed. I was a programmer and got kind of pushed to work on layout and routing. And so I worked on this problem that I knew nothing about, that like I could barely understand any of the code because it was like 20 years of like janky like C++ that used to be C, and then like C++ was invented, and then they started switching over to it. So like it was a bad fit. I'm not. I'm not that great of an engineer.
So you're saying you don't like solving
games.
puzzles here, Zach? Is that what I'm hearing?
I don't like solving bad. Well, so actually, that's kind of related, right? It is a puzzle, but it's a bad one. It has poor it has poor feedback, right? Like it takes forever to learn why, and there's like you have to learn too much at once to make any progress.
Yeah.
And honestly, I think a lot of these things we do on these decisions, like the design decisions we make for our puzzles, are all about how do we take this real life engineering experience and make it less horrible, right? How can we improve on it? And so we'll get back in that second. But yeah, so I worked at Microsoft, and like I came home, was so like wanted to do something important and meaningful that I made a bunch of games. And during that time, I made Space Chem like at night and on the weekends, and it actually kind of took off. And because of all the stuff we'd done in the past, we made this game called Space Chem, which was our first commercial game, and it found some people who loved it on the internet and some people on gaming sites back when gaming sites actually like kind of drove things more than they do now. And people loved it, and we sold a bunch of copies, and we got it on Steam right when Steam was starting to do digital distribution, and there were way fewer titles than there are now.
Yeah, less noise.
Yeah. And so me and one of my buddies, we quit Microsoft and we started a game studio. And we did that. We made Ironclad Tactics. We made some educational games. Almost went out of business when Ironclad Tactics didn't do as well as we thought it would. That's notably our only non-engineering puzzle game that we've ever made. So we kind of verged off into something weird. And then we made Infinifactory. We made TIS 100. At that point, we'd been doing it for a couple of years, and I got kind of burnt out, honestly. And it's hard when you get burnt out when you run a company, when everybody else depends on you to like lead the way, because it's like, well, I'm just going to I need to take a bunch of time off. Like, you guys keep doing the thing that I told you to. Wait, that doesn't. No. So we just kind of, and having never really been in this position before, we shut down the studio. And so everybody kind of who was there kind of split off, and we kept making money off the games, but nobody was actually doing anything at Zachtronics for a period of about a year. I went off and worked at Valve. I actually, before that, I interviewed at Microsoft again. It was just like, yeah, no, this is not happening. I can't go back.
Right.
But I interviewed at Valve and worked there for 10 months. I worked on VR stuff. It was really cool because that's when VR was starting to take off.
Yep.
And so it like I definitely felt like I had to be part of this thing that's happening, which I have since gotten out of my system.
So are you a fan of VR? Did you just think it wasn't as good as you thought, or are you a big fan of VR?
I think there was a little bit of fear of missing out when everybody in the industry was kind of moving towards it being a cool thing. And then now that I've actually seen it firsthand, it's just like, I don't know if this is going to be the thing.
That's my opinion
point.
too. It doesn't do anything for me. Like, it's kind of cutesy, but it doesn't push
Have you
my
tried
buttons.
the Vive?
No.
I have.
What's
I have.
So the Vive is amazing. Like it's so cool, and it actually like adding your hands adds a level of immersion where it's like wow, it's way more immersive. But like it's still like as a game designer, it's not like like when I think like I want to make these kind of games about systems, it's like wow, it'd be way easier to make this if it wasn't in VR.
Yeah.
And so
interesting.
I'm sure it adds a whole nother level of complexity and order of magnitude more complexity.
And it's a whole new dimension of having to be in 3D, and it's in there. Yeah, there's so many things. So I don't know. It's good and bad, and it may or may not catch on. Who knows? I don't know the future. But
did you know the hardware group there? I mean, I think all of them, almost all of them have been on the show at this point. Yeah.
Oh, cool. Yeah, I did. I worked on the software side of things, but I worked on I worked on a game, but I also worked on like the calibration software when you set up your Vive.
Okay.
And,
cool. Yep.
And so like all of that like had to be done pretty closely with the hardware guys, and also like I in the past and when I was in college I had done hardware stuff. I'd made games about hardware. Obviously it was super cool, so I'd like go over and just like see what they were up to and watch them like hot glue stuff and test stuff and other oscilloscopes. It was super fun. And that was kind of where the inspiration for Shenzhen.io came from. So
really?
like when I wrapped up at Valve, I had actually managed to find a company called Alliance that would buy Zachtronics because I was tired of running the business, but I wasn't tired of making games.
Right.
And so we found this like perfect opportunity, and we work for them now, and that's how we made Shenzhen.io. And
how do you shop out a game company like that? Like basically a two-man game company, was it? I'm assuming it's a two-person.
Anywhere between currently we're 4, and we've peaked as high as like 6 or 8.
How do you like? Do you just randomly cold call bigger companies? How do you do it? How do you?
Just like all things in life, just weird personal connections.
Right.
When we made educational games, we did it for a company called Amplify that was owned by News Corp. News Corp spent like $1 billion or something making this like tablet-based curriculum. Yeah. And a small portion of it was making educational indie games to go on those tablets. And so we were part of that, and we made 3 totally original, way cool educational games for them. And one of the writers there, so after that project came crashing down, one of the writers there ended up at this company Alliance. I don't even know how he ended up there. And then, but I still knew him from Alliance. And then I was joking with a friend. I'm like, oh, find me $1 million and we'll make another indie game. And lo and behold, we found a company to buy us.
Awesome.
And it's great. We get the creative freedom we need to do our weird stuff.
Are there any downsides that you found
Not yet
to selling it? No? Okay.
Honestly, no. It's like I had to do all the business stuff before, and I was like okay at it, but it's really not my strength. Like I'm really like a creative person, not a business person, and so it's I'm way happier now than before when I had to like worry about all the business stuff.
Right. That's well, and so you're obviously in Seattle. We didn't actually say that at the top, but are you still in Seattle? Or are you working remote?
Yeah.
Cool. What is the scene like there? I guess I still haven't been there, unfortunately, but
for
software, hardware, whatever.
Oh, there's a lot of big companies. There's a lot of big software companies here.
Hello, Microsoft.
Yeah, Microsoft and Amazon. Increasingly, Amazon
right,
really dominating the like. They're just constantly hiring tons and tons of people.
They are a graduate vacuum cleaner, are they? Going around.
Just an everybody vacuum cleaner, yeah. So they're like, Microsoft is still huge on the like one side of the lake, and on the other side in Seattle, Amazon is growing and growing and growing.
Does that impact your ability though? Like, I guess I don't really understand where game development happens either. I don't know if like is that like one of the big places that it all happens, or
it's surprisingly scattered. I think there are a lot of game studios here. There's definitely a lot of startup-y indie game studios. Although it's hard to tell like how many of them there are everywhere, because like, I swear to God, there's just like a million. Like there's like an entire VR incubator in Seattle. I just learned about this, where it's just filled with like all these little startups trying to make VR games and VR stuff. And it's just there's a lot of like small stuff like that. I'm kind of out of touch. I'm not really out like in touch with like the indie stuff anymore. Like when I first started doing it, that was when everybody was starting to do indie stuff. Like Braid, Jonathan Blow's Braid had just come out, and he made a bunch of money on Xbox Live, and like and everybody's like, whoa, there's money in making indie games. And that was at the beginning. There were lots of like there was a pretty tight-knit community here, and I was kind of part of that. But like over time, like like people come and go. A lot of the first round indie people, like they didn't make a second game, right? We're relatively privileged in that we've been able to make we have 5 games on Steam, plus all the crappy ones I made before. Not a lot of people make like 5 commercial games as indies, and it's just because it hasn't been a thing for that long. And so like know, it gets to the point where now when I try to go to an indie meetup, I don't know anybody there, and it's just like, whatever. We're just in sort of like a weird, like mature but incredibly tiny and irrelevant space,
Right?
And it's strange.
There is one thing that I do not see here is that where's the apps? Where's the iPhone games? Isn't that where all the money is
Zachtronics,
nowadays,
you
or
mean?
is it grown? Yeah.
It's okay. So this happened with Facebook gaming before app
yeah.
gaming, right?
Facebook gaming?
Yeah, when Farmville was
like
the thing.
Zynga.
Oh,
Yeah, and Zynga?
Oh God, is that
Yeah.
that crap that keeps popping up on my phone? That's why I don't use Facebook.
So years ago, I mean, this was probably like 2008. Like I don't know, I'm hazy on the years. It was it was like in 2008. It was when Facebook and Facebook gaming started becoming really big, and all of a sudden there were tons of people spending tons of money and playing all these Facebook games, and people were like, oh, like are all gamers just playing Facebook games now? It's like no.
Right.
What actually happened is that all the gamers who weren't on Facebook games kept playing the games they were playing. But all these people who weren't these people who weren't gamers started playing games on Facebook. And so what happened is that by growing out in this new direction and this new audience, it actually like the total number of gamers got bigger. And I think the exact same thing happened with phones, is that phone
mobiles,
games
yep. Exactly.
Yeah, exactly. It represents a totally new segment of people who are playing games, and people who played hardcore quote unquote games, who when they're on the toilet need mobile games to play. And so like the pie just keeps getting bigger and bigger, and like inexplicably, like on Steam, you know, people have been saying for years that PC gaming is either dead or not dead. But like on Steam, there's so many people buying games, and great for us, there's so many people buying really like weird, difficult, you know, challenging, strange games. And I don't like there is certainly money on phones. It is quite possible
money,
that
Angry Birds, you know, or is that the rare exception?
It's kind of like from a per title basis, it's kind of the rare exception. Like GDC is the Game Developers Conference, and so like 1 or 2 years ago when I was there, we were talking about mobile games, and somebody was saying that Clash of Clans, 60% of the money being made on the App Store was going to one game, Clash of Clans.
Whoa.
Wow,
that's a
really?
power distribution,
Is that how they can afford those TV commercials and crap like that?
Oh yeah, with celebrities and
With
Super Bowl.
what's the one with Arnold? Is that the one with Arnold Schwarzenegger?
I don't even know.
He's got one, and then
Kate, what's her name?
yeah, exactly.
And there's a battleship one with Steven Seagal, who's
What, really?
advertising some battleship game.
Man.
So it is certainly big in its own way, but like PC gaming is also still big, and that's like our games probably wouldn't thrive as well on mobile just because the players are different. They're looking for a different kind of experience than on PC.
Right, okay. So you did. So you knew that you wouldn't be successful there, so you didn't even try.
Yeah. We've tried.
Right.
We ported Space Chem to iOS, where it did okay, but not nearly as well as on PC. And you know, PC's our place. Like that's our favorite platform, because that's where the people who are playing on that love our, like they, you know, more so than other platforms, they really are able to find and enjoy our content.
Yeah.
Now here's where I want to get into the nitty gritty of games. Let's start by porting. How easy is it to port something like Space Chem over to iOS? It's not like, oh, you push a button and it ports over to iOS.
I don't even know what you're writing code in. I mean, I saw a Unity base.
Exactly.
Right?
Yeah.
So we write all of our games in C#. Okay. And this is before, I mean, like we had like our own custom, with Space Chem, we had our own OpenGL, like just our custom engine in C#. For Infinifactory and TIS 100, we switched to Unity, and we've since switched back to a custom engine in C#. But all of our stuff is in C# because we love it. It's a great language.
Did you write the engine first from scratch with the intention that it would be used for multiple games?
No, I mean, our notion of an engine is pretty hazy. Like some game programmers will say, I'm going to build an engine, and they'll spend like years and years working on like trying to re-implement the wheel. Like our engine, quote unquote, is just like a way that we can draw stuff to the screen and read the keyboard, and just as we need more features, we just kind of hack it in. Like our philosophy.
It's like an API basically for you for the game
exactly.
Stuff. Yeah.
Like during the year that I was at Valve, our like lead programmer Keith was like sort of off in the went up at the mountain and like discovered a whole new way of programming games, and when I came back from Valve and he came down from the mountain,
there were stone tablets and
yeah, exactly. And it's like, so our philosophy now is very much just like, if you need something, program it right then and there. Like, don't try to predict the future. Don't do more work than you have to. Yep. Like, just keep it, like, you can refactor stuff when it sucks, you know, and just try to, like, we don't have that many programmers working on stuff. It's just the two of us. So we're able to be really agile and just not do anything that we don't need. And Like that's our graphic stuff is really like there's a thing in games programming where usually in a program you don't want it to run continuously. Like you want it to like cede control back to the user. In a game it just needs to run continuously. And so usually people like they'll split it up into like, oh, you have a draw loop and an update loop. And so like our philosophy is just like we have one function that just says like do the game. And it's a very simple There's a programmer like Casey Muratori who worked with Jonathan Blow on The Witness or something. They were somehow connected, and he had this big thing where he live streamed writing a game in a game engine from scratch, and it's very like this kind of like low tech like approach to games programming. Like he's very low tech, very old school, but like there's a lot of kind of modern lessons in looking at that kind of stuff, and so I think Keith learned a lot from that too.
Now, I will toot my own horn here. I know more about this than you do, Chris, because I have actually written and published my own game. Did you know that?
Okay. Is it Snake? I don't know, Dave. Like, I don't know how that's relevant at all. Like, looking at these, I'm guessing it's a little bit more.
Back in the day, hexagonal Othello. I wrote my own game. This is like early 90s. So, like, and this is what I wanted to, like, I wrote my own engine, in air quotes, to display display the stuff on the screen and generate the the images and stuff that I needed. But I look at even games from 15 years ago, even ones at the time, I go, how the hell do they do all these photorealistic graphics and everything else? How do you it's just mind-boggling to me that the amount of
I guess the attachment of code to the
games.
Graphical stuff is very confusing to me as well.
Please explain. Magic.
Okay, so,
okay, that explains it. End of show. Thanks, Zach.
Yeah. Ta-da!
Time now.
Yeah. Graphics programming is obviously more complicated than I can talk about now.
Is there an engine is there an engine off the shelf that does it? I know like all those like the Doom engine and stuff. Like people can write their own game in a week, their own Doom game in a weekend because the engine's there with all the graphics and everything, right?
So like fundamentally, like it's a beautiful synergy of hardware and software, and like you're writing code obviously, and code can move stuff around in memory. We understand how code works. Yes.
Yeah.
Most days. Yes.
So graphics hardware is the other half of it. And so the simplest, a simple graphics hardware is just like a memory buffer when you put like ASCII values into it, it mirrors those to the screen and like a grid. Yep. And that's like a simple like character-based graphics display. And then from there you could also do like a bitmap graphics. So you have
that's about my level is the bitmap.
Yeah, exactly. And so that's how like a lot of old 2D like graphics stuff would work is that each pixel is a byte, and then depending on what bits you put in that byte, it changes the color of that pixel. And then there's just a bunch of them in like linear memory somewhere, and then that gets drawn to the screen. And that's good for like 2D stuff, and you can do 3D stuff. It's like Doom, that was done by in software kind of figuring out which pixels go where if there's like a wall at a certain distance and a certain angle, and you're doing that all in software, but that's hard. It turns out that having to do something for that many pixels it's slow, right? Because you have to basically like loop over all the pixels, or there's like tons of like people who are way smarter than me making this fast.
It's difficult in sequential programming.
Exactly.
Right? And that's sequential processing more.
Exactly.
Yep.
And so people started building graphics cards that were well suited to this problem of like, okay, well, instead of doing a small number of things in linear order, we actually need to do a bunch of things in parallel. Like we can do them in parallel. I guess I just jumped to the punchline. But because these pixels are relatively independent, we can calculate them in parallel. And so flash forward 30 years, like we get to where graphics cards are now, is that they're these specialized little computers within your computers.
They're freaking supercomputers.
Okay, they're supercomputer. Yeah, I guess it depends. Little relative to the physical size. I don't know. They're computers within your computers. We don't have to make any judgments about their size. But they're optimized for parallel processing, because like you take your data for your world or whatever, and when you calculate what should show up in a certain pixel, it doesn't matter what shows up in the adjacent pixels to calculate pixels. So you can kind of just like fan it all out and calculate them in parallel. And a lot of graphics programming over the years, like it used to be like in the 90s when they started having 3D graphics cards, that there was something called the fixed pipeline, which is where, like there's a setting that you can, like there's a register somewhere that you can write to turn fog on or off or change the fog distance. And there's, there's registers registers, and I guess you never actually access the registers directly. Like that's for the job of the driver. But
yep.
there's all these different fixed features you can turn on in this fixed pipeline, and now it's very much not like that. It's all programmable pipeline, and so you write code that then gets downloaded and run on this graphics card, this computer within your computer, and then that determines what it should do for every pixel on the screen. And then that's sort of where we are now with computer graphics.
So can you do that for, say, a character? Like you've got, like in one of your games here, I'm looking at the screenshot for Ironclad Tactics, and it's got this like human-looking character. Do you draw? How do you? So
that game is actually entirely 2D. So for 2D stuff, it's actually really similar to what it was 30 years ago. Is that we have an image, an image that has a bunch of frames for that animation, and we blit, we copy. I guess technically it's not. So actually, Ironclad Tactics is a lie. It's 2D, but it's 3D accelerated. And so we're drawing a 3D shape that is just a square onto the screen. And we're drawing a bunch of squares where we ignore depth and just draw them in order. And you can take the graphics card and configure it to go into this mode where you can do 2D games. If we were doing a 3D game like Infinifactory, you would have like a model, you would have like a geometric data that represents a character, and then you take that and you feed that to the graphics card, and you tell it you give it rules for how to actually draw the little pixels based on what color it sees. It's actually really complicated, and again, this is above my pay grade.
Okay, well,
how do you think we feel, man?
That's the thing. How do you generate the photorealistic artwork, the characters?
A lot of it comes down to lighting.
Are there tools? Are there
so a lot of it comes down to data and lighting, I think. Is probably safe to say.
Sure,
anybody who actually knows about this is just going to be like face palming while they listen to me try to explain this.
Right.
But, high res. Okay, so when I was working at Valve on VR games, when you're in VR, you can jam objects into your face, and it's supposed to feel realistic, which means that for it to look really good, you want it to be insanely detailed, right? Mm-hmm. And I worked on The Lab, which is the Valve's VR game that came out with the Vive, and notable, a lot of the content in there is very high resolution. And so when you do take this object and jam it in your face, you're just like, whoa, it's real. And so that comes from when you model something, adding a lot of detail just as data that describes all the different contours of it. You think that if you took something off your desk and scanned it in and captured all of the information about it, you'd have a lot of data, but you'd also have a realistic representation of it. And so there's all sorts of tricks that people do there, because if you were to actually capture every little pinpoint data as an uncompressed kind of thing, it would actually be a lot of data. And so there's all kinds of tricks where things are made out of polygons, out of simple shapes, and then you can do tricks where you texture it, so you paint on the surface detail, but instead of just painting on color, you can also paint on information about how recessed it is into it. And so you can have something that's just a single flat polygon, but you're texturing in detail to say oh, this part should dip down and this part should dip up. And then when you go to render it, you can actually do lots of advanced math to kind of calculate what it would look like if it was offset based off of that information. And so it's a really interesting problem of choosing how to represent your data to efficiently store something that, because the end result of computer graphics is it's something that your eyes and your brain perceive. We're not really trying to truthfully represent the objects. We're just trying to trick people. And so it's what's the most efficient representation for efficiently tricking people's faces and brains?
Right. Well, and don't they talk about when you're focusing on something, that's where, peripheral vision is super low resolution effectively anyways, right? But something that you're focused on, obviously you're using all of the information is coming in your brain that's super high definition as well, if you're your hands in front of your face. But there is still data around all the other light that's hitting your cornea, right?
Yeah, it's the fact that exactly. So, and rendering is a lot like that, and that there are things about human brains that we're taking into account here, and we can take shortcuts because of it. Same thing with lighting. There's lots of ways that you can, this is things that people started figuring out in the 80s and 90s and probably before that too, that you can kind of, lighting is complicated. The behavior of light is super complicated, but we can kind of cheat, and there are simple models that we can use that actually come progressively, closer to accurately representing light. But, back then it was just blend and Phong shaders, or these classic shaders. Yeah. Shaders is a term for graphics programs that determine how to draw pixels and how to color stuff. And so There are these simple models that people were really impressed, right? Because it's like, wow, it looks like a real thing in a computer. Like nowadays it's all about like ambient occlusion and making it so, like this like light is actually scattering all around and bouncing off of surfaces. And it's, you could on one hand calculate how every like little photon of light bounces, but that's hard, right? And that's one of those things that computers aren't good at naturally because it's not like a good sequential problem. And so some people move towards ways that you can calculate that data in real time, right? Like ray tracing is all about that, but real-time ray tracing isn't quite here for games yet, or might never be, who knows. And
is that because of the processing power required?
Yeah, it's not convenient. The way that like the n squared, kind of the
right.
the what do you call that? It's been too long, but like the number of iterations you have to do is not convenient for quickly doing it. But they'll do things where like they'll fire off those calculations in not real time and then save the result out and then use that as, again, like textured data coming in. Or you can just paint on something that looks like ambient occlusion and call it a day, like in the texture. We did a lot of that with Infinifactory. So all these like fancy rendering techniques we're talking about are things that are generally like we did not take advantage of because we had like one artist working on the game for a lot of it, and when we scaled up, we still had to do it in a cheap way. I mean, like God, like Call of Duty, a game like Call of Duty, like an artist will spend like months and months and months making a model of a gun. Right?
Yeah, that's crazy.
Because it's like it's so big on the screen, like it's a character in the game is this gun, and they take forever to make, and like we don't have that kind of resources. Like we have to make a game with a very small team very quickly, and we have to do the entire game. And so we did a lot of like really cheap techniques, like just kind of painting on ambient occlusion to make the blocks look, and it's like yeah, that'll pass, that'll work. We actually, amusingly, our artist was really fascinated with like PlayStation 2 era games because they didn't have a lot of these techniques, but they made some really pretty looking games just like by painting on the right stuff. And he's like a painter, like a digital painter, like that's like his kind of focus area. And so we took all these old techniques from old games and kind of resurrected them and made a pretty attractive looking game considering how little like resources we had.
Yeah. So about that though, so sometimes some of your games also take on the more low res look, right? I mean, like some of that is played. You played to that as well, or no? I mean,
in the past, so I used to do my own artwork in the past, and so that was like many other indie game developers before. I guess before they were doing that thing, a lot of people make pixelated games. Before that, I discovered too that hey, as an untalented not artist, I can make shitty pixel art and it'll pass as like this looks like graphics, and I think you still see a lot of that now with indie games just because pixel art is accessible in a way that traditional art, like game art, is not.
Now we have to ask about this because on your Wikipedia page, you are credited in the first line as basically being the inventor of the genre that led to Minecraft.
Yeah, definitely.
That's
a thing.
So why weren't you Minecraft?
Because there's a lot of reasons.
Okay.
Most importantly, I didn't. Right.
I don't know much about Minecraft other than I know it was big, but
it is a very big game. Yeah. It is perhaps the biggest indie game of all time.
Is it? How much did they sell it for?
So he sold it to Microsoft for $2.5 billion. I'm pretty sure.
Jesus.
Yeah, right. And that's after it had been out for many, many years and had made them a bunch of money. And it's so I started the genre with a game that was nothing like Minecraft. And I think like any kind of creative person, right? Like the way you achieve creative success is that you come up with some ideas of your own, and then you look out and see like where's the genre at currently, what's the state of the art, like what in there would really synergize well with what I want to do, and that's absolutely what happened. It just wasn't me who did it. But somebody's got to take that first step.
Yeah, of course.
So are you well known for this? Does it lead to fame and fortune, or everyone's? Yeah, I was going to say for.
Well, my life is a lot more low key than his, so in some ways, I think I'm in a better position. I don't know if I could have taken all of that. Oh my God,
you couldn't handle the $1 billion. That would have been.
Yeah, well, hey man, with $1 billion comes a lot. You get billionaire problems, and billionaire problems are serious. So I'm not even kidding. You really like it. It totally distorts everything from what I've heard. I guess I don't say that with any sort of having been there, but yeah, it's dodged a bullet there.
So I guess the thing that I wonder about is I don't quite. So I've seen Minecraft. I'm looking at Infiniminer, which is your game. What is the difference? I'm sorry. It looks
So the difference is that Infiniminer has like a cool mechanic where you build stuff out of blocks, and like a pretty terrible game that wraps it. And versus in Minecraft, it has the same awesome block building mechanic, but it has what was actually kind of a novel like mechanic at the time, which is it was once described at a GDC talk I went to as fantasy of labor, which is where you get to do fake work, right? And so Minecraft is all about like you go around and you punch trees and you get their wood, and then you can build stuff out of that wood. And and if you just had wood, it wouldn't be as satisfying because you punched that tree and got that wood. And
Gotcha.
this is sort of like it's a thing that's going on in game development right now, which is where there have been so many, like there's just been this huge renaissance of like arguably like bullshit game design stuff that makes games super addictive, right?
Right.
Like crafting and like there's all these kind of genres that are like, especially on PC, are really popular, and they're kind of like Minecraft kind of got there first. Like Minecraft was the first game to popularize these kind of things, and I think arguably like sure the block building part is an important part of Minecraft and part of the fun, but like the fact that it was one of the earlier games to really just kind of drill down and be all about these super compelling addictive mechanics, like that's really, I think, a huge part of the success.
Yeah.
And it really set the stage for like game development now, which is all about like on mobile games especially, right? Like it's all about like trying to set up like compulsive gameplay stuff to get people hooked. I don't want to ramble too much because I sound like I'm crazy, but
no. So like I told you when I was emailing with you that I actually don't play video games very specifically because I almost failed out of college because of them. Because I
which one?
It was Return to Castle Wolfenstein.
Oh wow!
Yeah. I mean, like nothing special, but it was just
that's
like
not even that good of a game, is it?
I know, but I just and every time I've tried since, it just is the same thing, and I just said never again. I like Kerbal, right? So I've talked to friends about Kerbal. They're like, "Oh, it's such a great game." I'm like, "That's awesome."
The space program for those.
Yeah, I will never ever play it because I'll go nuts. I'll just
Some people say that about our games, especially. They're just like, why would I play this game when I could just write actual code?
Well, and so that's what I wanted to get towards. So you mentioned like, okay, people doing work, like fake work, whatever you called it, right? But
it's still playing games. Don't make any.
So where is the crossover? I mean, are people learning assembly code from your game? Are they learning electronics assembly from Shenzhen IO? I mean, like what do you see? What do you expect to see from this? Are we going to see the next brand of the next generation of electrical engineers coming from?
I think they're learning
games?
an interest rather than they're possibly learning some system skills. I would imagine. I'm sure Zach can set it straight, but I think
agree.
It's more of an interest thing.
Yeah. It's like our games are sort of deliberately not transferable. That we teach you things that we made up so that way they'd be easy to teach you. And real life is not so
like
convenient.
a Z80 processor.
Yeah, I was just gonna say the exact same thing. Yeah, there is somebody on Reddit who was like, "Wow, like I'm surprised by how close Shenzhen IO is to real life." They started doing some Z80 assembling for the Game Boy, and they wrote this huge write up about like, well, it's totally different in these ways, but like there's some, but there are some similarities in the core. Like it's not that they learned how to do it from that, but like it kind of primed them a little bit, and they can see like once you know multiple things and you're able to compare them, like it kind of gives you a context to learn new things more easily. It's like people who learn lots of languages, right? Like you can say, oh, it's like this but different, as opposed to having to learn it for the first time where it's not like anything you've ever seen before.
Well, and it's tenacity as well. I mean, to be honest, it's tenacity, right? I mean, so we talk about it a lot on this show. We've had guests to talk about as well, like electronics is hard because you have to just keep trying it, right? You have to, or coding, programming is hard because you have to keep trying new solutions, and that seems like that's precisely what you're teaching, right?
I kind of suspect that's more of a selection bias than an actual like teaching. Like I don't think our games teach you how to be patient. I just think they punish you if you're not.
Right. But I mean, the same way with electronics, though, like like you don't see people that are impatient like building huge circuit boards, right? It just doesn't work, right? I mean, like it's
exactly.
Yeah, there's that same bias. So
yeah, definitely. I do want to separate, like when I talk about fantasy of labor, like their game, like our games could kind of be considered like fantasy of labor, but it's like intellectual labor. There's a lot of other games that are just like you're just doing like you're punching trees,
clicking a button
and stuff. You're clicking a button a bunch. Like incremental games are sort of like a purified distillation of this, where you're just like clicking a button to get more points, and then you spend those points to get machines that get you more points, and like gotta make that number bigger.
Dopamine.
Exactly. Yeah. Like there's something wired into us where we love gathering and hunting and stuff.
Yeah.
And people
I think we're a very sad species. I think
we're trying our best.
We're doomed.
So what's your take on like dystopian, like Ready Player One type stuff? You got any?
Oh, I couldn't read that book.
You couldn't like it, you said?
I couldn't read that book.
Oh, no?
Couldn't get through it.
Oh, I loved it.
But I don't know. I mean, you got to be more specific, I guess. Like
I don't know, like the whole, like, I guess that's another tie to the VR type of thing, but like, it's a VR dystopia where people are all living in the games, but also there's the educational component to it as well. Like that's the positive stuff they talk about.
Yeah.
So
This is something I actually think about a lot, because when we were making educational games, I actually had a bit of a crisis towards the end of realizing, oh God, nobody is learning anything from these games. We're literally just funneling money from by proxy from schools to make games that we think are fun, but like nobody's gonna learn anything. And it's like, but it was pretty hard. I had a hard time. Like we stopped making educational games, and I kind of lost interest because it's like they're not really working, and because we're making games, but like they have to be fun games, but in the process, like it sort of like loses its ability to be educational, because it turns out that like education is not really well defined, like what that means.
Right.
And I think that's sort of like, to answer your question, the thing I learned through all of these games and making this stuff is that like games, like escapism isn't evil and education isn't good, right? And I think a lot of people talk about education as especially like it's a kind of monolithic valuable thing,
right?
But like
it's we need to
like
increase education. Yes,
exactly. Yeah, everybody can get behind that. Yeah. Like it's not like that's kind of not how it actually works, and you just kind of can't approach it like that. You can't think about it like it's a monolithic thing, and like it's not, it's, I don't know. So when I think of games, it's like, not all games are bad, and escapism isn't bad, and like to some degree, like people need, we're getting all this like leisure time through all of our technology, but like that doesn't mean we necessarily have anything good to do with it. And so in some ways, like making things to do for fun, like it's kind of an important thing as much as anything else could be considered important.
Sure. Yeah, definitely.
I think education is not that valuable unless there is the interest to go along with it.
Absolutely. Yeah. And just as like in the service of being a human being, right? Like we have to do something. You have to do something to make a living, right? Because you have to be productive in some way that matters to people, and you often need skills to do that, and like that's it.
So what about this? So people are taking the way I first learned about Shenzhen.io is I was on YouTube and I was clicking around, and all of my stuff is all the stuff I look at on there is electronics, and then so I started recommending these videos on there. And then I saw people were using it to build Tetris, and I was like, what the hell am I looking at? So, what's
that? What's going on?
So they're using your game about programming to create a program that plays a game.
Yeah. So our games, a lot of our games they're sort of engines in the way that like we create the set of tools that allows players to emergently combine their parts in order to accomplish a goal. And for the core part of the game, we tell you we give you that goal. We say, like in Shenzhen.io is all about building fake electronics. And so these
great.
Close to our hearts.
Up your alley, right. Yeah.
Me and Dave also often build fake electronics on this show.
Yeah.
Ours are probably faker.
We don't build much.
So we set out these challenges. Like we'll say, like the game takes place in like the near future. You're an engineer who couldn't find a job because all the electrical engineering jobs are mysteriously gone, and so you move to Shenzhen, China, to get a job and build some stuff, because that's what you were meant to do. And so your character, you go to China and you get a job at this little engineering company that's making, they're making stuff.
And you have to use squat toilets and, like...
Well, we don't go into that part.
No, you don't go into that sort of depth. No.
Yeah. Dave's realism is not... too deep, man. Too deep.
We have been told that we did a lot of research and we interviewed some people.
I want to hear about that at some point as well.
To capture... Yeah. We interviewed Bunny like everybody else who needs to know about Shenzhen. But it was really good, yeah. So it's about that. So you're working at this company, and like the product managers there are like, hey, we think there's great demand for an electronic sandwich maker that for Americans, and like they push a button, it'll make them a sandwich, and the little American flag will pop up when it's done. And
you have to say sudo first.
What?
You have to say sudo first, right?
Oh yeah.
Yeah.
Yeah,
Can you
exactly.
please make it so that if they make an Internet of Things device, it like explodes and locks them out of the game permanently?
So we've got some stuff that's kind of jabs at current technology. Like we have
Nice.
some, there's a little buzzer that goes on your VR helmet. So when somebody rings a little doorbell, it buzzes your helmet. So you know to like stop doing what you're doing in VR and like that they need
Come
your
back to reality.
attention.
Yeah.
Come back to reality. Pull up your pants. So we have a lot of jabs like that at sort of like the current trends. I think we have some spam. You get spam. All the stories told through email.
Yeah,
And so you
I
get
saw
spam,
that.
and one of our spam is about antivirus for your house because like your fridge will get infected and all your food will go bad and like Internet of Things kind of like weird.
Dave had his food all go bad. His
yes, I
his
did.
vacation. Yeah.
Was
There
it
you
a
go.
Russian hacker or was it just a general
it was a
circuit
dodgy
breaker.
circuit breaker.
Oh, okay. Well, that's those are old school problems. Well, this game takes place in the future.
Russian
so.
hackers. Yeah. Well.
Yeah. So so I forget how we got. Oh, right. So the challenge is to finally awkwardly get back to your question. So our we give people these challenges like build this VR buzzer. So what it is that there's an input for like a signal, like a radio is gonna, I think it was like a radio, there's like a radio receiver that tells you when the button is pushed, and you need to create like a little alternating pulse to drive this little like vibrating buzzer thing, so that way the person will know that someone wants their attention. And the puzzle is actually framed as there's a little like story thing that explains it, and then there's a set of timing diagrams, and it says like, here's your input, here's your output that your circuit should generate. And so we give you this timing diagram with the story, and it's your job to assemble microcontrollers and electrical components, like all these fake electrical components, to generate the specified output when the input happens. And then you run it through a test suite, and then we've verified that your thing is what, the beauties of automated testing. It verifies that you built what you were expected to do. And then you win you've solved the puzzle. And because you've solved it, we can then compare your score against everybody else. We can say, how much did all the components cost that were in your solution?
Friggin' weird.
Like how many yen did it cost you to design your thing? And like each chip has like a little cost on it.
Zach,
And
I literally cannot believe anyone does this for fun.
oh,
Like,
I know.
so many people do this for
it's
fun.
So weird.
I was going to say, this seems like the most colossal waste of human,
Welcome-
capability in.
I
What
love
are
it
you doing
so
to our
much.
species? What are you doing?
Welcome to the
People could
future,
be doing
dude.
real stuff.
This is friggin' 2017, man.
Yeah.
This is great. I love it.
It is. So the beauty, I think, is that you don't have to, like, it's so, like, so I did electronics in college and I did programming in college, and there's a reason that I only do one of those now. And you were talking before about like electronics does require a lot of patience and tenacity that I don't have. And I think that's the beauty of a game
Well,
like
in that
Shenzhen.
style, though. In that style, right? You have patience and tenacity. You've built this.
No, I have less. I have strictly less, and
Come
that's why
on,
I
man.
write
You're building a
software.
huge
Yeah,
game that
but
does
no,
this.
But it
software-
closes the feedback loop.
It
guess.
does. You can write a routine and it runs, and boom, you get that little hit.
Yeah,
I've got
And it's
LEDs.
not-
I've got LEDs. Come on, that's cool.
Yeah, no, there's a much
Yeah.
bigger. There's a much bigger, much bigger threshold hysteresis type level
Okay,
that you have to
fine,
get
fine,
through
fine,
with
fine,
hardware than there is
So-
on software.
So by making a game about the joys of hardware, like it's something that like people will dabble with their Arduinos, but they're never going to be able to quote unquote like make a bunch of stuff. And there's also like a story element to it, right? Like you get the story that goes, you get to be part of the story. You get to learn about a subculture of engineers in Shenzhen that is a real thing that's going on now. So like it hits all these different things. We try
Yeah.
to make our games be like, I think of it as like, like some games are made to be like really easily digestible. They're smooth. They're round. They're perfectly polished. Like you can't even pick them up because they're just like ours are like really nubbly, and they have all these little bits coming off that are interesting and give it texture. And that's what we try to do with our games is make this little package of just like you can just like immerse yourself into this world where you go work there instead of like killing stuff, but like it's still just as real and it's intensely satisfying to the right kind of person.
If anyone listening right now happens to be in Shenzhen or knows people in Shenzhen, and if you ever see this on a resume, you have to call us or email us or do anything to get in contact with us, because then you know what's going to happen, right? I mean, at some
We
point,
get a lot of jokes about that. People saying like putting I beat TIS 100, they put it on their resume or something.
Yeah.
Somebody has probably.
I mean, is there value to that? I mean, like there must be, right? Like I refuse to believe this is entertainment only. That's what I'm getting towards.
I think that's the beauty of it, is that it's entertaining. So I was going to say one thing. You thought that was ridiculous. The game doesn't have any tutorials in it. Instead, it comes with like a now 40-page manual that's filled with data sheets and, and application notes. We sold it as a binder at the beginning when the game came out. Yeah. So, and they're all written. Everybody's like, oh my God, this is like, there'll be parts that are missing because you only have the English documentation, and you only find out from your Chinese coworkers halfway through the game that there's a better way to do something. And there's a data sheet for like a PGA kind of like Gatorade thing that's only in Chinese, so it's completely untranslated. So you have to go online and like find out like what the data sheet says because it's all in Chinese. And, like we did all that kind of stuff.
You are sadistic.
But it's great. It's immersive
and realistic. Yeah, of course. Oh my God.
Yeah. To answer your question, Chris, is it of any value? It's a relative thing. It's better than playing Minecraft.
I think there's value in Minecraft
from
too,
a resume
honestly.
point of view, if I saw somebody had on the resume, I got 1 million points or whatever in Minecraft.
Well, what if they built
a
someone built a 6502 in Minecraft though? Like, what about then? I don't know. Like, there's like nuances to it, right?
Oh, yeah, but that's a special case.
That kind of takes back to your question about Tetris, is that, so there's a core game in Shenzhen, but the engine that we provide to allow players to solve our puzzles is also an engine that they can use to build their own things. And in fact, we provide tools for this purpose. And so in Shenzhen, there's a component where you can load an image into the game and create like a custom LCD screen, like an old like 1980s LCD game. Yeah. And like they can be touch sensitive. So when the user clicks on it, you get data back from it about where they touched. And so you can use these things to create your own like open-ended games within the game. And for us, that's like a thing that's fun for players and also like a marketing thing, right? Because when people make something cool, they share it, and then they're like, oh, what's that? That's a game.
You would share it,
Yeah, that's a big part of how we do marketing, is just to make a game that allows players to be awesome in a way that makes them want to share it with their friends.
Wow. That's awesome.
I'm gonna say here though, but I can predict the future here, that it's like people watching playing video games instead of actually playing them. I can see the same thing happening here with Shenzhen IO. Somebody builds a game in Shenzhen IO, and then people don't bother building their own games. They just download and play the game inside Shenzhen IO.
That's true with some games. I don't think Shenzhen IO probably isn't complicated enough. You kind of need something like there are a lot of spatial constraints in Shenzhen IO that make stuff like that hard. But there absolutely are games, like there's a game called Gary's Mod, which has been out for forever.
Oh, I've heard of that.
And people don't really play that game. Some people kind of play that game, but more so they play games that other people have created inside of that game.
Yeah.
And it's like a game that's also a game engine, and there's stuff like that pops up, like StarCraft, right, or Warcraft, like those like real-time strategy games. That there's a map that somebody made with custom rules birthed an entire like what is now the most popular game genre, arguably MOBAs, right? That started off as just a. So do you know what a MOBA is?
No. I don't know.
Okay, so a MOBA is multiplayer online battle arena. It's a game where you control a character, and it's like a 5v5 team battle, and you're trying to like everybody has like their own special moves. So like maybe somebody's really fast and can do a lot of damage quickly, but has low health. So if they're stuck somewhere, they'll die instantly. Like you have all these characters that are asymmetrically balanced, and then you fight against other players who are controlling them. So you do like 5-on-5, like real human versus human battles. And this is like a huge, like unbelievably huge genre now. People play esports. People get paid way more than you and I ever will to play these games and win them.
Yeah.
And but this game genre was actually birthed out of just a map that somebody made, like in an old real-time strategy games, which is now a genre that's arguably dead. People like some of them allowed people to create their own maps, which had their own rules. And so somebody made a custom map with custom rules where you controlled a single unit instead of a bunch of them, like in RTS games, and you fight against other players. And like this one map birthed it birthed a genre that now dwarfs the original game from the games from which it spawned.
That's crazy.
And that was people playing a game inside a game.
Yeah, right.
It's
probably not going to happen in
human
Shenzhen,
race.
But...
This is
that's a million monkeys with a million typewriters problem, isn't it? Like if you give people, if it's a big enough thing, and then people want to be creative with it, it's just the medium they're given to do it with, right? I mean, I think that's a positive thing, actually. And that's why systems like yours, where you do have these open-ended, I'm sure that probably breeds it even more than other systems, right? Like you're not going to have a first-person shooter without a map modding type thing that's going to go and create something new, right?
Yeah, so a lot of our players are programmers, and so they do very programmery kind of things in it. So they might not go viral in the same way as a MOBA, But,
right, of course.
Yeah, but yeah, I mean, it's like, I mean, right now we're using a tool that was made for a different purpose to record this podcast, right? And it's
That's
allowing
true.
it's a creative tool.
Yeah,
It wasn't even a creative tool, but it's allowing us to do something creative and make something,
Sure,
and share it with people.
Right, it's like
And
ricochet effect, or
Yeah.
just, the assets.
Well, that's
are
the key
so worth
word.
it.
We're making something and sharing
Yes.
it with people. What's your opinion of these people who just sit there and watch PewDiePie play?
Weirdly, he's creating something that people want, right? Like he's entertaining
He is,
them. And
obviously.
in the same way that people whoever's listening to this, they're like doing whatever and just listening to us, right? But like they're
Well, I'm doing the same
Hopefully
thing.
they're
We're
soldering
doing
right
the
now.
same
Yeah, exactly,
thing now,
yeah.
but it's
I think it's exactly the same, and I think it's definitely, from a content perspective, it's cheaper to produce than like a game, right? Like a game takes us at best like 4 months. For many people, like a lot longer, right? You just kind of have to work at something for months and years, and then you create something that people can enjoy. But I mean, it's all content. I don't know. I think our content's pretty awesome, quite
Yes,
frankly.
and I want to get back to that as well. So so first off, okay, so these are just kind of adding on to one another. You said Shenzhen was the Shenzhen IO was kind of from the Valve group, but also just other experiences. Mm-hmm. What kind of research what are you doing? What are you doing? You say you talked to Bunny, but like, did you go over there? Did you work there? Like, who is advising you on all this stuff?
So first off, I mean, like it's hard to say like, oh, our stuff is so authentic that we know despite having never been there. No, we've actually had like a fair number of people like who were either like expats who worked in China or people who are from China who are like, wow, this is really like, this is stunning. Like the developers must have lived there and worked there because it's stunningly accurate. So I'm not just trying to toot my own horn, but trying to establish some of the stuff we've seen.
Yeah. I mean, it looks as legit as anything I've seen. So like but not that much,
So our writer had been to China a couple times, like when he was like in high school and college, and I went to Japan and Korea, but not to China. But that's where I learned a lot about like the excitement of traveling somewhere where you have no idea what's going on and being completely in over your head. Just like, we can go to Korea for a couple days, we can wing it. I don't know any Korean. Yeah, so it was exciting. But like none of us have ever worked in Shenzhen. I've never really done like an electronics job, but we've been able to, like, a combination of like, I read a lot of stuff on the internet about engineering and engineering culture, and we talked to Bunny about sort of like the Shenzhen, the same thing he tells everybody about when they want to know about Shenzhen, about just like what it's like with the factories and how like iterative they are, and like their unique take on IP that puts them in an interesting position to be able to innovate. Yeah. I'm not trying to take a stance,
No, of course.
I'm not moralizing.
You mentioned that you had a writer there. What is your team? What is a team made of that you need to make a game like this?
So
you said you had an artist. I think you had a graphic.
Yeah, every team has a different
writer.
composition. We run with I do design and programming and like creative direction, like studio head kind of. There's a reason that we're called Zachtronics and my name is Zach. So I have my unique position, and then we have a programmer who also does design. We went to college together, so we've been designing stuff together for years.
But they're doing the grunt programming.
They do the hard programming. He's much better at programming than I am.
Was the mountain, the guy, the one up the mountain?
Yeah, the guy who went up the mountain and came back with a whole new way to make games. Yeah. And then we have an artist, Kyle, who we found him through like a friend of a friend of a friend kind of situation, and he is our core artist now. And he did the art, like all the art for Shenzhen. And
so how do you draw the art? Do you like sketch it on a tablet or something?
He uses a big honkin' Wacom tablet or Wacom tablet, and it just drives directly and controls the mouse, but has like information about like pressure and pen tilt and stuff. And so his approach is very like painterly, and so he just kind of paints stuff and uses brushes, and just like a real painter would cover paint with other paint to create like blended and stuff, that he just paints stuff. And if you look at Shenzhen, you'll see it's not rendered, like it's not 3D rendered. It's all 2D sprite work, and like all the little like highlights and lowlights and lighting information is all painted in, and they're all just 2D sprites, and we just composite them in code. So like he's very like 2D painterly. He also did a lot of the art for Infinifactory. So where he would paint do a little sketch of what the like the 3D block should look like, and then we shipped it to a studio in the Philippines that did the modeling for us, and then they would ship it back, and then he would paint the textures to have all the little details that he wanted. And so like he's not much of a 3D guy, but we were able to work around this by having somebody else do the hard part for us.
That's three people.
That's three, and then the fourth is our writer, who is Matthew. He does writing, and he does music, and he does sound. And so basically like the whole like the tone, like the tone, like both from like a story perspective and musical perspective, which in my mind are like super interleaved, right? Like you can tell people one thing with the story with the words, but your music needs to go along with that and like inform their emotions on it too. And so the fact that we have somebody in house doing both of them now, when we used to kind of outsource a lot of that stuff, has been like I think a huge improvement for our process.
Can you see, are games that complex these days, or people have such high expectations? Is it impossible for a single person to do it all and produce a compelling modern game?
I mean, I would say anecdotally, not at all. I mean, there's a game that just came out last year or the year before called Stardew Valley. It was one guy who worked on it for years and years and years, and it came out, and he's now like a multimillionaire.
Good on.
Right? It did very well.
Is that the exception?
Every indie game is the exception.
Right.
Yeah. Right? Okay. Like you can't just go into and just say, I mean, honestly, it's like that with a lot of businesses, right? Like you can't just go in and say, I'm going to be a successful, like, this doer, right? Like you have to have an angle.
Electronics YouTuber.
Exactly. Yeah. You have to have the right set of circumstances that make it possible, and it's especially true with games, but it's also true with literally everything else.
Yeah, man,
fascinating.
I actually remember the first one that I saw of your stuff, and I was super confused, and I don't actually know how to say it.
Constructor? Oh,
Ruckengineer? Is that how you say it?
Ruckengineer? I don't know. It's like a made up. It's supposed to look like it's German, but it's really not.
Yeah.
That was like my first big popular game. That was on Hackaday. Like, years and years ago. That was how we got started. Is that I made that game and I managed to get it on Hackaday, and all of a sudden a bunch of people found it and were looking at my stuff, and they were all like engineers and engineering type people.
Yeah.
And it took off from there.
That's literally what got you started though too.
Kind of. I mean, I'd made games before it, but that was the game that put me on the map, quote unquote. I mean, it would still take years and years and years till I made like a dime off it, but that was what got it started.
Well,
and that was back in like the blog era of internet.
Right. I remembered because it was like, so it's like you're probing on a board for like security stuff, right? Or is that
it's about reverse engineering. So there's only like 4 levels, but each level is a device that you have a voltage, quote unquote. It's all like fake electronics, but it's probably the closest to any kind of real electronics that we've ever done. You have a voltage probe, and you also have a thing that can generate voltage pulses, and then you have something that's kind of like a JTAG kind of thing where you connect it up and you can read and write registers inside the chip. And then you have a serial port where you can read and write serial data. And you kind of, there's all these little test points in the boards, and you hook up the probes and try to figure out what they are and what they do and how the device is working. And you try to like you hack it to get it to do something.
Yeah.
And the story of it, you're an engineer for like some group of like rebel group that's fighting against, like, I don't know, it never goes into explaining any of it, but you're part of some sort of like military resistance, and you're hacking stuff. And so like you hack open a lock, and then you hack you hack like past like a biometric thing on a gun, and then you hack like an encrypted like communicator and try to find out a message, and you hack a bomb that's about to explode in your face.
Sweet.
I think I heard about this from Joe Grand. Maybe we talked about it when he was on the show too. So he was on the show a long time ago, but yeah, I think he was the one, and I was, because he does like a lot of the JTAG reverse engineering stuff. So Another fan of your work. I just remember being very frustrated with it. It's the game. Like the further back you go in our back catalog, the more frustrating and awkward our games get. We have brute forced our way through learning how to make more usable games, and even then, I think a lot of people would say we're not there yet.
So you get feedback on that, like this is too hard, and I just give up.
Oh yeah, I mean when we started, we got feedback from people complaining about stuff. We've since, like a long time ago, switched to metrics. After Space Chem came out, I got invited to go out to lunch with Robin Walker from Valve, and this was way before I worked there. And he was asking me a bunch of questions. He's like, "How do you know like if your levels are working? How do you know if it's too hard?" I'm just kind of like I didn't have a good answer. And that was sort of when it dawned on me, is that like all these kind of things that we'd like to know, we could totally figure them out if we started instrumenting our code and adding metrics and finding out what people are doing. And so now,
so it feeds data back to you as they're playing?
It does.
Right. Okay.
And like
some
everybody,
people don't
literally
like that though.
Yeah. Every application you run is feeding data about you back to headquarters.
Yeah, sorry, Dave.
So sorry. Yeah, we keep it.
A cell phone.
It's weird. It's creepy, right? You realize like if we're doing this casually, literally everybody else is too. And we keep it anonymous.
For people listening on the amphour.com right now, we're also tracking you with Google Analytics and Libsyn, and like it's like, of course, right? We all do that. Yeah, anything streaming for sure. Yeah,
definitely. So the most important thing, the only data that I really care about, honestly, is the data that has benefited us the most so far, which is knowing which puzzles people beat, which they don't, how long it takes them.
That would be the main metric, I think. Would be how long it takes.
Because it's a puzzle game, especially. We really want to know. We used to just have to go off people saying, like, this level's too hard, and, like, that was it. That was all we could do, right? And
have you pulled out data where there's, like, you've found out what the attention span limit is before people give up? Like, is it 10 minutes?
I don't know why. That's the problem with metrics. You never know why anything happened. You just know that it did. So the one thing that was super useful is that when we launched Infinifactory, we put a survey at the end of every level. And so we were collecting objective data, but we were also asking people subjective questions. And we were able to find stats that correlated with like answers to questions. Like it turned out that there was a pretty direct, we're not really statisticians, so like none of this is really like true.
What was the
if you know anything.
Zach?
Yeah, I don't know. But
93% confident.
I wish I don't even know. I would say I wish I knew, but I don't even care. So I'm sufficiently confident that there is a link between players who self-report that a puzzle that they just beat was too hard with the number of people that load up a level and then never beat it. And just like usually just quit playing the game. Like they get to that puzzle, they're just like, nope, I'm done with this game, right? It actually correlates pretty directly. Like they spike in the same place. With people saying, like, I was able to beat that level, but I think it was too hard. Because you really can't take the opinion of somebody who hasn't beaten something, because of course they're going to say it was too hard, because they gave up. But somebody who is able to beat something and then says, no, I was able to beat it, but that was too hard.
Right.
Like, that's more of the kind of thing we want to calibrate for. And so we use that now. And so with Infinifactory, it was really obvious. We could see these huge spikes where, like, it turns out that for a game, even though the game gets harder, people complaining about the levels and saying they're too hard should actually be flat. Right? Because you want people to be constantly challenged. And we could actually see that for the most part, it was constantly flat. And then there were a couple levels where it spiked up just for no reason. And that told us that those are the puzzles that we should change and make easier.
So do you actually go and change the puzzles then to make, like, do you update the games over time then?
Oh, yes, absolutely. I mean, the beauty of releasing a game on PC is that we could release 5 updates a day if we wanted. On Xbox, they charge you like $10,000 for an update, like if you do it too often.
What?
Like, it's crazy. They charge you tons of money and you have to go through cert again and you have to like go through all these like on Steam it's literally I push a button on my computer and then like 5 minutes later everybody has the latest version of the game on Steam.
Sweet.
And I can do that as much as I want, as often as I want, whenever. It's amazing. So we push changes all the time, and with Shenzhen's specifically, I had a really hard time figuring out like how what order to put the levels in for Shenzhen because there's not really like a direct increase in skills. Like it really is just like build this thing, and like it can vary wildly. And so I was constantly throughout the game rearranging the puzzles in it and adding them and changing them. And
so critical question then: does that mean that at some point you can have an engineer in the game listening to the amp hour while they're working? Like
what does that mean?
To this show,
you could stream our audio
the amp hour
directly into the game
while your coworker in Shenzhen is,
or you can play
working.
EEV blog videos in a side window up on the screen because this is what real engineers do.
We're just trying to abuse.
You're
the power.
proposing features.
Yes.
I guess so.
I'm sorry. We're done active development on the game right now, so we're not planning to add any features. Next time maybe.
Okay.
Worth a shot,
all right,
Chris.
fine.
I do have a funny EEV blog story. Which was when we were ramping up on Shenzhen, we had a little party at my house where we hung out and we went out for dumplings and we watched a bunch of videos on YouTube about all the things that were related to this game. And part of that was explaining how electronics works to our artist and our writer. And so the way to do this, of course, was to fire up some videos of EV blog where you're tearing stuff apart. And it's like, oh yeah, you see that thing right there? Like that's what that looks like. Because we're really going more for like a visual feel than anything. Like our artist doesn't actually need to understand electronics because it's not real, but he needs to know what electronics look and feel like.
Wait, you did this at the end of development after you were done?
The beginning.
The beginning. Okay.
Yeah.
And he needs to know what stuff to get excited about and what stuff not.
Exactly. And so we specifically the video we watched I'm pretty sure we watched the whole thing was tearing apart the weird like German prototype like touchscreen computer.
Oh, that tablet thing.
And it was just like glued together and it just kept getting worse and worse the further you go. Yeah, so we watched that and it was,
That's awesome.
That has now reached almost 1 million views. That's what my second most popular video now. That's just crazy.
Yeah.
Oh man.
Yeah, so that informed a lot of Shenzhen, apparently.
Brilliant.
Yeah.
All right. Great. Thanks, Zach. This is great. I'm not going to hear about this all the time for the rest of my life now. So, okay, so one last question. We could talk, I could talk your ear off all night, and we shouldn't do that, but...
I don't care. I have no plans.
I am so curious just about this educational piece. I know that you said it's not important, but, like, there's got to be something here. Right. And I mean, I do education. Dave does education. I'm very interested in this, but like, what about just the assembly, right? So you're doing, so another game, TIS 100, right? That's assembly, but like, is that legit? I mean, is Zach, is anything
None
real?
of it's legit.
Nothing. Yeah. So if you could see me right now, I'm kind of smirking, right? Because like, I mean, like our games aren't educational with a capital E. Right?
I don't want it to be institutionally educational. I just want it to be like glancing education. I want someone to be like, oh, okay, I think I get this now.
Why didn't you use real Atmel or microchip opcodes, for example? Why not base it on a real processor?
Yeah, so the interesting thing, so this is actually a thing a lot of people, we actually get asked this question a lot when we talk about this game with press people, and they're like, why didn't you, like, or what language did you pick? Or why didn't you use an existing language? And the reality is that from a game design perspective, the language is part of the game design. And in fact, it's the most important part because the language sets out what you can do and it sets out how you learn it. And it actually dictates everything about the game. Is that up until like the last minute of developing Shenzhen.io, we were changing the language. And specifically, like there were, so it's sort of a nuanced thing with the game. So we have two ways that there's two kinds of inputs and outputs in Shenzhen.io. We have this is a funny thing. Okay, so originally there were three. There were analog, digital, and something we called XBus, which is like our version of like an SPI or an I2C kind of thing.
Right.
Yep.
And I'd made this distinction between analog and digital signals because like not every pin on a microcontroller is an analog to digital converter. Like there are limitations there are asymmetries there, but like trying to explain to our writer like the difference between analog and digital, like he just was not but like the reason why is because there's really not like a difference. Like they're kind of like digital is just like the idea of a digital signal is just kind of like a convention built on top of the fact that everything is analog.
Correct.
And And so, like, we're just like, wait, this isn't helping at all. Like, we should just get rid of, if we want to do like a sine wave or a square wave, like on like an analog thing, we can. It's fine. It'll work. And so we simplified the notion of them being separate just down into one thing. But we couldn't call it like analog because it's not really analog. It's actually discrete between 0 and 100. Like incremental integers. And so we called it simple I/O because it's simple and it's just a number. And the way it works is that when you output a simple I/O value, you just set it and it just constantly outputting that value until you come back to it later, like it's latched. And you can read it at any time from another thing reading it. And then we have XBus, which is like our SPI I2C kind of thing, where you can, like, a processor can go to write, but it won't actually, it'll block until somebody else goes to read, which will also block if there's nobody else writing. And then, but once there's both a read and a write, they'll stop blocking and then they'll transmit the value. And like it's a clean, like, it's a synchronized protocol. And this allows you to send values between different nodes without having to worry about timing, because it'll just automatically pause until. But we have this extra, and that was something we did in TIS 100. Everything was the equivalent of XBus. That it was you were programming this like multi-core computer with like an insane number of cores, but they were all synchronized and could send data back and forth. So sort of like a transputer architecture, or like a green arrays kind of chip.
Wow, whatever happened to transputers?
We made a game about them, that's what.
They were the thing back in the 80s.
Yeah, well, they're coming back thanks to us. So, but yeah, so we have Simple I/O and XBus, and now I'm struggling to remember why I started talking about this.
Well, just I was asking about the realness of the assembly language, and Dave asked why you said because you were changing the language up until the last minute.
Right. Okay, sorry. So there's also this thing that makes it more complex in Shenzhen.io, which is that there's timing diagrams. And so the way you kind of do it, the way you generate a square wave is you'd write you'd write a value of 100 to your simple I/O pin, and then you'd sleep for one time unit, and then you write a value of 0, and then you sleep for one time unit, and that would that would do what you would expect. That's kind of like a microcontroller-y thing. You're bit banging out like a square wave, and and we wanted to have that be a thing. And then the question comes like, what happens when things are blocked? And then so say you go to like you have two nodes. One goes to write to the other one with XBus, so it's blocked on the right, but then the other one goes to sleep. Well, naturally, the thing is just that because one of them is sleeping for one time unit and the other one is blocked on that other one, time would just advance while it was blocked, right? Mm-hmm. It's kind of an abstract concept. It's hard to explain, but the idea that like when something is blocked on a read or a write, time should be allowed to pass if everybody else is sleeping, because it kind of simulates like we're not actually we're not simulating stuff in discrete steps like 1,000 microseconds or whatever. You know, like
I guess the problem here is that both Chris and I can.
We're trying to solve the actual problem here.
Imagine that all this is possible by simulating a real microcontroller.
Yeah. So
why not?
Exactly. So the problem
it's less fun. It sounds. I mean, like honestly, it sounds like it's less fun and less flexible and less. You got a lot of other crap to deal with. Honestly.
Yeah, well, so we get to the thing that I'm almost done. Oh, sorry, I'm wrapping up. So, so we had this problem where everything could get stuck waiting on each other, and then time would pass, and none of our playtesters could figure it out. And it was like, from a programming standpoint, it was totally correct, and some of our really advanced players who were playtesting it totally understood, and most of them didn't. And so we actually had to change the language and change the way that like the architecture worked in order to like make it behave in a way that people were able to learn. And if we were using an off-the-shelf language, we wouldn't have been able to do that.
Right, you would have put like a tooltip or something like that to be no, you have to do this now.
Right.
Yeah, exactly.
Little Microsoft paperclip pops up and helps you.
That's sort of the beauty. Yeah, exactly. Right. Honestly, we have a mascot called Chippy, who's a chip who pops up and offers you tips, but they're interface tips, so it's appropriate.
All tied together. Oh god.
Yeah, our mascot. Somebody cosplayed as him. There's a picture on Steam. But yeah, so
fantastic.
The beauty of
playing.
Wow.
The beauty of these games is that we're creating the entire system, and like if we were actually trying to teach something real, which was the case when we were making educational games, you don't get to tweak your system. You just have to. If there's something that's hard to explain about starch metabolism, you just got to hike up your pants and explain it anyway. And like if people don't get it, well, that's on them, right? Versus we're allowed to kind of change the problem to suit our solution. And that's why I wouldn't call our games like educational with a capital E, but like in reality, like you start getting into some pretty hairy stuff about like, well, what does educational even mean? But there's no point in calling it that because nobody wants any of that, right? Like,
right, yeah, of course. Yeah.
Okay, so I'm going to pull another fiction reference back in here. Have you ever read Diamond Age? How about that one?
Oh yeah, absolutely. That was actually the idea of that was hugely inspirational when we were creating educational games.
Okay, that's awesome. So, and if people don't know, there's basically a primer in there where it interacts with the child using it, and that helps to learn. But like what you're talking about, you could keep doing. You could keep like modifying this language so that it goes more towards I don't know. Like
but there's almost no value in making a bunch of like AVR programmers, right? Like
it's true.
Right. Like
I know.
Like it's just not, and I think that's kind of the thing is with any kind of education you're assessing like it's easy to just say that like it's good for the sake of education, but it's like in reality it's like we don't need to teach those skills, right?
No,
like,
we don't because there's hardware and software platforms out there that do that,
and it changes all the time, and people pick it up if they need to, and they won't if they don't, and it's like we're really here trying to make something that's fun, but in a way that maybe is not a way that is different, like fundamentally different from a game about murdering people.
Well, I like that, but I think maybe even at the end of the day, again, they might be learning all these other things that, like you said, AVR. You don't need to teach AVR because that might go away at some point, or anything could go away at some point. But if you teach the underlying concepts and you kind of train the tenacity muscle and like all those other things. I know you'll never call it educational, but damn it, I'm going to think of it as educational because I don't know. I'm going to tell everybody about this thing. Like it's crazy.
I kind of feel like there's a notion of like how maybe not educational something is, but how enriching it is.
That's a much better word. Yeah.
We all know that there's some entertainment out there that's like junk food, and there's some of it that's less like junk food, and like. It's on a spectrum. It depends on who you are, and like it's So I like to think we're making something that is healthier than a lot of the other options out there. Certainly, I mean I'm certainly a snob, right? Like I hate mobile games. I think they're like a vast majority of them are a blight on society. I used to feel really conflicted because I was like I'm a game designer and they're a game designer. Are we doing the same thing? It's like no. Like people who make slot machines are also game
You're
designers.
You're trying to justify your existence.
Yeah, like in Rick and Morty when Jerry's just popping the balloons. balloons on the tablet. That's all the game is popping balloons.
Yeah, exactly. And it's like they're making a different product. They're doing a different thing than we are. It's okay. Like I don't have to compare myself. I don't have to feel bad because they make like buckets of money doing stuff that I would never do.
Yeah.
Like
bastards.
It's
well,
okay.
You did say too, like, so when we were talking, you seemed like you were more encouraged to come on the Amp Hour versus like a video game podcast. Is there like cultural stuff that's different? I mean, like I know that we are not video game, obviously, but like, is there something about the video game industry that is not fun?
It's just games are kind of boring, like as a topic.
They wouldn't
right?
get it. They probably wouldn't get it.
A lot of them don't get it, and honestly,
I don't get this stuff, Dave. I don't know what he's doing.
If you guys should
it.
play this.
Come on.
Honestly, it would be awesome to see Dave, especially see you do a let's play of the beginning of Shenzhen IO.
Let's play.
Like it would be incredible because you could complain about all the stuff in it that's ridiculous.
That's easy content, actually.
It
I'm
is.
looking for some.
I
I'm
might break
feeling
my rule
lazy
for
at the
this, Zach,
moment.
I
I'll
gotta
do some
say.
easy
I'll
content.
send you guys copies. That's easy
Yes,
to do.
please.
Yeah. So okay.
It's for Windows, is it? Because I'm
It's
a
Windows,
Windows
Mac,
person.
and Linux. Yeah.
Okay. Yep.
Yeah.
Yep.
Definitely.
Yes, please. I will do a let's play.
I was gonna say these games come from a place of being passionate, not about gaming, but being passionate about engineering. Honestly,
Right.
and like I express myself through games as a medium, but it's really about I honestly don't have a passion for games in general. Like there are people who do, and you can see by the games they make. They're very gamey games. Like this is all. I have a passion for
This
for
tastes
things
a little
about.
gamey.
Yeah. Yes, maybe a little bit, but I don't know. It's a passion for engineering, and I feel like that's something that's easier to talk about when we're focused on the engineering, and we can talk about the engineering part.
Yeah. Well, Zach, this has been the most unbelievable and wonderful discovery that we found out that you were doing this stuff. Obviously, I'm so glad you are doing this stuff. I mean, whatever.
Me too.
If it's enriching, if it's education, I don't care what it is. It's awesome. That's all I know. And thank you for doing this. It's really cool.
I'm glad you guys appreciate it.
Where can people find you, and how do they purchase this game? Because I think some of the people listening are going to be like, hell yes, I'm doing this.
Oh yeah. So for the record, it's even if you've never played a game before, these are a great way to start playing a game if you're also an electrical engineer, because you've got the hard part down. You just have to figure out the part that all the 10-year-olds manage to figure out.
Right.
So if you go to Zachtronics.com, you can find all of our games. The best way to buy them, we don't actually sell them directly. They're available on a platform called Steam, which is like the world's biggest like game buying platform for digital games. So what you do is you go on Steam's website and you sign up for an account, and then you'll download the client. And I know it's a pain in the ass. It's DRM. You make a Steam account, and then you can buy games on it, and it adds them to your library, and then you can download them and play them from anywhere. And this is by far like
My
the best way.
enthusiasm level, has just dropped 10 points.
The other way to buy most of our games, but not all of them, is on a site called like Good Old Games or the Humble Bundle store, where we sell DRM free versions of most of our games. And you just you make an account so you can give them money, and then they just send you an installer that you can download.
That sounds that's my level.
But Shenzhen IO is not yet on GOG, but it's on Humble Store. So if you need DRM free.
Anyway.
Okay.
Yes.
All right.
Yeah, but you want the Steam version because it has leaderboards, and then you guys can add each other as friends, and then you can compete with each other. And so this is the thing that's benefit. That's the upside of DRM is that you get fun free features for giving away your soul, and and you can compete with each other. So when you beat a puzzle, you'll see that Chris, for example, you'll see that Dave did better than you, and then you'll be driven.
My fraudulent nature will be called out and in big block letters.
Or maybe Dave's fraudulent nature will be called out in big block letters. You'll have to find out.
Yeah, that's scary. Awesome.
Yeah. But my email, honestly, like if anybody gets confused with how to buy our games, my email address is on our website. It's Zach@Zachtronics.com. You can email me, and I will tell you how to do it.
Yep.
We're very easy to reach.
Sweet.
That's great. Well, Zach, thank you so much.
Thanks for having me.
been awesome.
I guarantee we'll talk to you soon because I want to talk more about this stuff.
Sounds good.
All right, thanks, man.
Thanks, mate. Catch you next time.